Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And this short video, another video in our series of videos dealing with algebra, and in particular quadratic equations, is going to present a derivation for the quadratic equation formula. We've probably seen this formula many times, and we've probably asked ourselves the question, well, where the hell did this formula come from? So the derivation is, I suppose, what we're really wanting to try to do is this is given, let's say, a quadratic, is given a quadratic of the form ax squared plus bx plus c is equal to 0. So given the quadratic of the form this, can we find solutions? That's values for x that when we substitute them into this quadratic, we get 0. Can we find solutions to this quadratic, or roots to this particular quadratic? And there's a formula. So given this quadratic, we have that the x's are equal to minus the b value plus or minus the square root of the square of the b plus 4 times a times c all over 2a. That's the quadratic formula that we've probably seen many times before, and I suppose really what we're trying to do is we're trying to provide a derivation of where the hell does this come from. Okay, so let's try to derive that. So let's say here's our derivation over here. Derivation, okay. The derivation is going to be over here. Okay, so let's have a look at the quadratic formula itself. Ax squared. Oh, whoops. Ax squared. Whoops. Ax squared plus bx plus c is equal to 0. Okay, and let's get it into the form where the coefficient in front of the x. What we're really going to do here is a technique called completing the square. Okay, and it's a well-established technique for helping us to factorize quadratic equations. It's called completing the square. But what we'll do first of all is we'll get this into a form where the coefficient of the x squared is actually equal to 1. And the way we do that is by dividing across each term by a. So if ax squared plus bx plus c is equal to 0, well then what we have is that x squared plus b over a, okay, times x plus c over a, okay, must also be equal to 0. Okay, just bringing the constant term over to the right hand side, this gives us x squared plus b over a, okay, of x must be equal to minus c over a, okay, minus that particular term there. Okay, now this is where we want to do our factorization. Okay. Now, the completing of the square technique tells us to look at the coefficient of the x. Okay, so we look at the coefficient of the x, we have it, okay, and then we square the result. So if we look at the coefficient of the x here, what we can actually see is the coefficient of the x, the coefficient okay, of the x term, okay, okay. The coefficient is b over a. Okay. Now what we should do is we should have that. Okay. So when I divide that by 2, that gives me b over 2a. And then finally what we should do is we should square that, which gives us b squared over 4a squared. Okay. So what the completion of the square tells us now to do is we should add this term to these terms. Okay. So what we'll do is this now gives us x squared plus b over a of x plus b squared over 4a squared must be equal to, well, we added this to the left hand side. Okay, so what I should do is I should add it to the right hand side to balance this equation off. So this gives us b squared over 4a squared, okay, minus c over a. Okay, and then what we do is we factor this particular thing here. Okay, now the way we have done this is through, as I said, the completion of the square. Okay, so what we've done is we've taken the coefficient of x and we've divided it by 2. We've halved this. So let's actually just do that. Let's halve this and see what we get. So this gives us x squared plus b over 2a of x plus b over 2a of x. See, b over 2a of x plus b over 2a of x gives us b over a of x. There's a half of them here and there's a half of them there, gives us the whole. Okay, so plus this term here plus b squared over 4a squared must be equal to b squared over 4a squared minus the negative c over a. Okay, you can actually see, let's concentrate on these two things here and also these two things here. There's a commonality here of, the commonality is x, so let's take the x out. So this gives us, it's x times x gives us x squared plus x times b over 2a would give us this particular thing here, would give us x times b over 2a would be b over 2a times x. Plus, now What's common here? Well, there's actually a b over